All right, let's get started. Welcome and thank you for joining today's webinar with Christian Zaya in Avoiding the Lesser-Known Gotchas in Linux Privilege Management. You're also joined by Beyond Trust Product Manager Paul Harper, who will run us through an overview of Beyond Trust after Christian's portion, so please stick around for that. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the chat box in the GoToMeeting console anytime throughout the webinar, and we'll cover your questions at the end during our Q&A time. Also, today's session is being recorded, and all registrants and attendees will receive a link to the recording and the slides within 1 business day from now. So now that that's all out of the way, I'd like to hand it on over to Christian, who will jump right in. Hello, Christian. Welcome. Thanks for being here today, and take it away.
Hello. So today I will be talking a little bit about privileges and user management on Linux platforms, and I hope I will present something interesting for you. Maybe not new, but there are a lot of things that the people tend to forget if they are not using them on a regular basis. So let's dig in. Just to start, I'm working for Secure, which is a consulting company that specializes in delivering security services all around the world. So let's start with presentation. The first thing, everyone should know it on Linux system, how our passwords are protected on local system. Shadow suite. Actually, in modern Linuxes, Shadow suite, when we are speaking about users, consists of 2 files, etc passwd, which contains username, user ID, primary user group. This concept is actually on Unix system quite common and on Linux systems. Obviously, a command for administrator, a path to home directory, and a shell that user will be using. The shadow file contains username and also information about password. Our passwords on Linux systems are being hashed. Hashing function is mathematically one-way function, which means that even if I would give you the result of hashing function, you cannot derive from that a plain text. On Linux system, we can use multiple hashing functions, MD5, SH1, Blowfish, SH215. Currently, on most modern distributions, we are using SH215, which is quite strong hashing function. No one found any problem with collisions. For instance, MD5, SH1 have problems with collision, which means that it's easier for others to create rainbow tables because they don't need to calculate all the hashes required to perform an attack. So I would like to demonstrate one thing from Shadow Suite. Let me just show you the structure here. The hashing function is determined by this string, and you can reference my small table in presentation, depending on the setup of the system, because obviously you, when you're an administrator, can enforce the hashing function being used in the system. You can set up according to your needs. However, I would recommend from security perspective, SHA 512 as a hashing function. It's the most secure to be used currently. The second part of an entry in etc shadow file is a salt. What is a salt? A salt is a unique value that is being appended to a plain text and before hashing function is applied. That means that the output looks like password plus hash and then plus salt, and then we have applied the hashing function and we've got a result, which is this part after the last $sign. This means that we cannot easily pre-compute all possible values of our plain text. Even if we have a lot of big computers to perform the computation, mathematically it's impossible. Because we would also, on top of hashing every plain text, hash every plain text with every possible salt. So it would be pretty complicated. But what are those entries? Star and semicolon. That means that user don't have a password. So most people think, okay, user doesn't have a password, he won't be able to log in. Is it true? Unfortunately, no. So it's good to know that even if a user doesn't have a password, he can authenticate against a Linux operating system using different means. So let me demonstrate that. Let's create a new user. I will change my context using su command, and please remember I'm using su command only because this is a presentation. I don't recommend using it in production. Use sudo instead, never use sudo. And let's generate SSH key for that user. Standard ping. Let's enable authentication using public-private key pair. We will just need to change permission on this file. Okay. And now we can try to log in. Okay. It works. So as you can see, the fact that user, let me just grab this one, doesn't have a password, doesn't mean that he cannot log into the system. This is the first thing. If you would like to prohibit users from logging to the system, you have to do another thing. You have to modify that user login shell. And login shells can be verified in etc passwd file. So if you would like to prohibit no PW user from logging, you just have to change it to false, for instance. Okay, so this is the first thing that people often forgot when configuring the systems, to verify the shells of the users. So just to show you complete thing, as you can see, false or has been no login. This is the shell that would prohibit the user from logging, even if the password is not set. Let's move further. What are potential attacks? Obviously, brute forcing the password or performing a dictionary attack. And actually, those attacks are not so simple in real life because a lot of system administrators learned their lesson and right now they auto-generate the password. However, I would always recommend to test your password against a brute force attack, a dictionary attack. This is very simple to do, and in my opinion you should do it on a regular basis because maybe someone prefer not to generate random passwords and use the same password on all the servers, and this password is not the best one. So let me switch back to demo. I'm a demo guy. I don't like the presentation slides. So user add -m will create a new user. Let's set a simple password for this user. ABCD is a nice password. As you can see, being a root user, I can easily overwritten the password policy settings on my system. This works exactly the same as on Windows operating system. So we'll just copy etc shadow, which contains a hash and a salt of my password, to temp, and I will use my Kali Linux to demonstrate how you can verify in real life. So just scp to copy the files, shadow, okay. We don't have enough time to break all the passwords, so I will just select one line with weak PW user. Okay, we've got what we need. And now I will use John the Ripper, and I will try to break that hash. I will use a custom dictionary prepared for that. Obviously, this is a small one because this is a presentation. However, you can easily download the dictionary files that are around and over 80 gigabytes. That would be much more effective test of the strength of the passwords in your organization. So let's use John. We provide the file with our hash, and the second parameter is our dictionary. Okay, and we'll keep it running. It will take a second. Meanwhile, I will prepare a new shadow file. Yep. To be used with Hashcat. Another tool in Hashcat will be performing a brute force attack. So cp new shadow, new hc shadow, and here we have to actually modify the contents of this file, because John the Ripper works with different file structure and Hashcat works with another one. So let's remove username, and we will remove also other components of etc shadow file. Okay, so basically what we leave inside is definition of hashing function, salt, and hash itself. Okay, this is ready for the next demo. And as you can see, ABCD. So my password wasn't the strongest one. We can also, for a demonstration purposes, do like this. It's better to see it in that way. Obviously, if I would use the whole etc shadow and I would try to break all the passwords, it would take much longer. But this is a small virtual machine, so we don't have enough resources, and also the presentation is time limited. So let's try to use Hashcat. This is quite simple, however a little bit more complicated than John. Hashcat, the first parameter, -m, we have to specify the hashing function that was used. So I know that we used SHA 512, so the parameter is -m 1800. Then we'll use specification of attack type, -3 brute force. We provide prepared file with our hash. And here I will actually speed up things a little bit because this is a presentation. So instead of trying to brute forcing all possible combination, I provided the beginning of the password AB. Then question mark L and question mark L. Second time means that I can replace this question mark L with any letter. So let's start. And the last parameter force, this is because I don't have GPU here. And we have to wait a little bit. You can always hit enter to see the status. Okay. In around 30-40 seconds, we should be done. Okay. Done. So we use the same trick, -- show as with John. And as you can see, ABCD. So this is how you should test all your passwords on Linux workstation and also on servers on a regular basis. Obviously, not using passwords pre-generated for the sake of the presentation as I did, but your real passwords. Okay. For a second, let's go back to my slides. And I would like to talk a little bit about strange concept. For many people, also it's a strange concept for me. So we are not alone. In Linux systems, we can set password also for groups, not only for users, but also for groups. However, that means that this password is shared between multiple individuals, which violates all security rules. However, in my opinion, every Linux administrator should know that there is such possibility built into Shadow Suite, and actually should set up monitoring and prevent usage of it. So let me demonstrate how it works in practice. Let's go to my CentOS machine, and we will start from adding 2 users. Let's add user Jim, user Bill. We also need a group. Let's call it developers. Let's assume that Jim and Bill are members of developers group. And here, instead of using a passwd command to set passwords for Jim and Bill, I will use passwd to set a password for developers group. Okay, password set. Let's create a folder. This is the most common use of shared group password. Home, developers. Okay. Now we have to set proper permissions because by default this folder belongs to root. So I would like to change group ownership for this folder. Okay, and right now I just need to allow members of developers a right permission. So developers. Now it looks cool. So owner, which is root, has all permissions on this folder, and the same goes to developers group. So now let's become Jim. Okay. Let's try to write something to developers. Echo test home developers test.txt. Okay, as you can see, permission denied. Why? Because Jim is not a member of developers group. Jim is only a member of Jim group. So what we can do? We have to enable this group. So SG developers, and Jim has to provide a password. Okay, let's verify. Now, as you can see, Jim is also a member of developers. Let's verify that it works. Okay, that works. So this is something that you should actually also remember and prepare a monitoring system. Let me just. I'm still Jim. Yep. As you can see, in a file, etc gshadow, exactly as for users in shadow file, the password is being stored using the same hashing function, the same concept of salt, and the hash of the password itself. So it's very easy to monitor for system administrators if someone set a password for a group or everything is correct. So generally, don't use it. I will show you several alternatives. However, one of the most common is the usage of sudo. And I would say this is the recommended option for me, or adding just a user to supplementary group, because on a Linux system, user can be a member of multiple group. If you are using group passwords, there is no accountability because there is no logging. You share a password with multiple users, and if something goes bad happen, you have no option to check and verify who did it. Okay, special file permission. SUID allows users to execute the file with permission of the owner. Most people think that actually this is always permissions of the root. This is not true. This is the permission of the owner of the file. Let me show you this on a small example. So here I've got a file, the owner is root. If I would switch to Jim, as you can see, this is actually so yep, effective with the ID of Jim, not root. Sorry, this didn't work as expected. And let me just do one quick thing. Jim, Jim. So now it should be what I was expecting to show you. Yep. Jim. Yes. So actually, real effective UID would be the user ID of the owner of the file. And actually, for us, it is important to remember that there are multiple files on the system that require this bit to be set on them. This is actually important, for instance, for very simple command, pass WD for changing passwords. So let's list those files on the system. we can do it with find. SUIT is number 4 in permissions, so we are checking all the files that for which that file permission start with 4. Let's do it like this. And so as you can see, most of the files with this bit set actually is responsible for managing something in the system, like sudo, su, passwd, gpasswd, and so on. So this is important to remember. Let's move a little bit forward. Another special permission is sgit. This is actually the number 2 in octal notation, and we can set it on folders. This is not dangerous for our systems, on contrary to SUIT executables. sgit is used for shared folders usually, so that multiple users can actually share the files that are being written in a single folder. And I would like to demonstrate this on a quick demo. For that, I would need 2 new users, but I would need to be root for that. And we'll create a new group called project. We'll create a shared folder for this group, so home project. We'll change ownership of this folder, so the owner would be root, group would be project, and we change permissions. So owner, all permissions, group, all permission, other, no permission at all. Home project. Okay, and let's just set sgit. So change mode git plus s home project like this, and let's become Alex for a second. Home project. Yep. Obviously, Alex is not a member of project group, but we'll correct it. So user mod minus small a means append a user to additional groups in Linux system. When you create a user is assigned to primary group, and then using user mod command you just assign the user to supplementary groups. It's project developers. Yeah. Sorry for today, but I returned from Africa today, so I am a little bit tired. Typos everywhere. And the same for user Mike. Yeah, now it works. Let's do the same as user Mike. And let's list home project. Okay, as you can see, the files are created as the files belonging to a group called project. So the owner is the user who created the file. However, group is set to the project because we set actually our SGIT on this folder. As you can see, if I change the folder to the home directory of user Mike, I created a new file. It is being assigned to primary group of user Mike, which is called Mike. So this is sometimes quite useful, especially if you manage the servers with Composer for PHP packages, Node.js, and you would like to share some folder between 2 or 3 people from application support. So because those packages are being downloaded into a single folder, and you would like each of the members of a support group to be able to overwrite those files without any issue. So you can follow this procedure. I did it several times in production, work without any issue. Okay, so the last special permission is sticky bit. It is usually set on shared folders, and it prevents users from deleting files owned by others. Okay, it can sound cryptic, but it makes sense. And because using sticky bit, even if someone has 5 permissions to this, I can prevent one user from deleting files that belongs to other users. So he would be able in such folder just delete his own files. So for that I also have a demo. So let me clear it, exit, and we'll prepare a new folder, home TMP. Okay, 777, so everyone can do whatever he wants. And let's become Mike. Okay. And let's create a new file as Mike. Okay, without any issues. Fine. So now let's become Alex. Home TMP. Okay. Home TMP Mike. And as you can see, without sticky bit, Alex was able to delete the file because he has all the permissions he needs to. Home TMP. Everyone can do everything. So let's just set sticky bit. This is done using the command O plus T, home TMP. Okay, and let's replay the demo. So let's become Mike. Let's become Alex. And let's try to remove it. Home TMP. Okay, as you can see, cannot remove operation not permitted. So I think right now it is clear for what purposes we can use sticky bit, for what purposes we are using Git. So for shared folders, sticky bit for preventing users from deleting other files, and suite, which is by many considered as a little bit unsafe, and this is true because actually most suite binaries in Linux system by default are owned by root, and you cannot change it because it's required for proper functioning of the Linux system. Generally, suite means that a user will execute executable in the context of the owner of the executable. So this should sum up special file permission on Linux. And now another thing, this is very common, Plugable authentication modules. PAM modules are used for multiple things, and actually everyone can create their own PAM modules for their application. There are multiple applications supported by PAM, but everyone can play a little bit with his own. Usually, administrators use PAM modules for setting up password policies. However, also, we can use PAM modules, for instance, for creating password history. And I will show you a demo of that, and I will describe what is the correct way of setting up password policies on Linux systems. So PAM actually allow you to regulate access to the system. All PAM configuration files can be found under etc pamd. So here you can see configuration files for multiple things. Today we'll work with system.auth, this file, and we'll play with setting up password history. It's not too complicated. Often it is required if you have to follow in your company some security standard. So generally, by default, password history is disabled on Linux systems. I would highly encourage you to enable it. Many security guides recommend you to set up a password history using PAM Unix library, like it's shown here. However, this is not the best method to do it, and let me demonstrate why. So, for setting up password history on Linux systems, we have to do some small preparations. First, we need to prepare a file that will store our password history. Okay. Now, we have to change ownership of that file, so only root has access to our password history. 600. Just to verify. Maybe this time I will use another command, stat, for that. Yep. Okay. And let's play a little bit. 1 second. I had something in that file. So let me just hope. Redo. Oh, okay. So now we have a clean system, much better. Okay. This is default setup. So let me comment it out. and using PAM Unix shared library, which I wouldn't recommend. However, you can find many websites which recommend such setup. So now we need to just change some passwords. Okay, and let's do it again. etc security. Okay, this is what I would like to demonstrate. You can see password history, correct? And at the beginning I talked a little bit about hashing function. So hopefully you can recognize that this is not SHA 512, which we should use. This is actually MD5, which is a hashing function that shouldn't be used. So my advice to you is actually verify what is written in the internet. So let me just quickly redo and show you the correct way, and we'll finish up after this demo. So the correct way is to use PAM PW history shared library, because this shared library will use the correct hashing function you set up on your system. In our case, the strongest one currently available. So let's do like this, and let's become Mike for a second. New password. And let's do that again. See. Okay, as you can see, right now we have the correct hashing function. So the best advice from this webinar, don't trust what is written in internet. Try to verify yourself and also know internals of your own system. So I think I will finish here, and I will give some chance to Beyond Trust to talk a little bit about their products.
Okay, all right. Thanks very much, Christian. That's some great stuff. Hoping people got some good information out of that. Obviously, it would be amiss if we didn't talk about some of the ways in which Beyond Trust can help you deal with these issues as well. Obviously you can go and look at your individual systems and check on what you've got set up for security, authentication, permissions, that sort of stuff. But off-the-shelf, commercial off-the-shelf type solutions really just help you get to that point quicker and manage security in a, well, basically quicker and easier fashion. So, so for anyone that's not aware, here at BeyondTrust, we do a range of different security solutions. We can deal with things like managing passwords on systems so that the passwords are changed on a frequent basis. One of the things I'm going to focus on today is basically managing least privilege or privilege on the endpoint. So endpoint least privilege, or just enough privilege, if that's another way you prefer to hear it. But also another thing that we do is actually an AD bridge. So I'm actually directly responsible here at BeyondTrust for the Unix and Linux solutions that we provide. So my main focus is least privilege on the Unix and Linux platform, effectively what a user can do or controlling the rights that they have when they've logged onto the box. But more importantly, or maybe more in relation to what Christian was just talking about, we also can control that initial part, the logging onto the system. So we do that with an AD bridge. So rather than having local user accounts, local groups, all of that information can be stored in Active Directory. That gives you basically one place to go and check for things like, do accounts have valid shells, making sure they got the right shells. But obviously, a single password for users to remember, single password policy. You have Active Directory type encryption for your passwords. It's just easier for users to use, easier for the help desk. It's much easier to integrate with IAM solutions, and again, like one place to go for your user needs, one place to create a user, one place to disable a user, one place to change a password. So again, that makes life a lot easier. But our AD bridge portion, doing centralized authentication, very, very quick and easy to demonstrate. So I figured today would actually wrap up with taking 5 or 10 minutes to talk more about our server privilege management. Again, the controlling of what the user can do after they've logged on. The two are pretty tightly linked. Again, as Christian was explaining, the rights of a file, the ownership, the user ownership, the group ownership, the permissions. Then things that again people often overlook. The set UID, the set group ID, sticky bit. There's a lot of things that go into that are closely tied to that user account and what that user can do. And again, Christian mentioned sudo. We're actually a replacement for sudo. So again, taking sudo to that next level, the sudo concept to the next level. But the main things that we provide are eliminating the sharing of privileged credentials. Again, the sharing of credentials for us doesn't matter whether it is a local user or a user like that's stored in LDAP. That can even be an AD user if you're using our AD bridge. But also auditing what that user can do. Centralized management of those users' permissions, and centralizing the audit trail, which can be things like moment in time stuff, who, what, where, and when, the actions that the user performs on a system, as well as full session recording. So everything the user sees, everything the user types. You can basically put a video camera on the screen for users. Obviously very important during certainly privileged sessions. But in addition, again, I talk about us being a sudo replacement, and we really don't have time in a session like today to go into all of the ways in which we go beyond what sudo offers. But I think one of the ones that's really important is the fact that we do system level control as opposed to command level control. So effectively, when you type a command in Unix, what you type on the keyboard and when you hit return may actually be different to what the system actually does. And two or three really easy examples there are when you symlink something. I mean, you can symlink my file to use a bin reboot, and then if you have the ability to execute that symlink, it will reboot the system, even though the command that you've typed has, other than that link to reboot, no direct correlation. You could also have a renamed binary if you somehow got on a system and could either install or rename the reboot command to something else, my file. Again, you could just run that and it would restart the system. And then probably the biggest the biggest pitfall that again people run into is if you call malicious or bad stuff from inside of a script. So being able to control stuff, let somebody run a script, but control the calls that actually happen inside that script. So those are some of the things that we do. So is sudo enough? It might be for some people, again, and particularly in smaller environments. And I would certainly recommend if, you know, like Christian said, don't use SU, don't be logging on directly as root, don't be sharing passwords or sharing accounts. So using sudo is definitely a highly recommended over the alternatives. But obviously, you know, there are limitations that you need to be aware of. And again, I'm not really here to knock sudo, just point out a couple of you know, things that often our customers, the key reasons why they look to move on to more of a commercial type solution. You know, issues with the login data, it's not tamper proof, it's sometimes hard to manage, hard to store, stored on the box by default, not having any support, you know, again, just having people to turn to help with best practices and to deal with like those more complicated environments. And obviously the management is actually, I would say probably the management and the limitations that are inherent with the sudo as policy language are probably the biggest reasons why people come to us. So Fabric for Unix Linux, again, I'm not going to go and read off everything around this. This will go through all of the individual steps. You know, it's the key things. You know, our policy language allows you to get a lot more fine-grained. We allow you to centralize all of that policy stuff. That policy is also dynamic. We offer advanced features like file integrity monitoring. Very important when you're talking about, you know, when you're going to allow somebody to run something with elevated permissions, you want to make sure that the something, and I'm doing air quotes, the something hasn't been compromised. So having file integrity monitoring on a system that employs least privilege is highly important. That's the sort of thing that gets wrapped up with a commercial solution like Fabric for Unix and Linux. You know, doing all the reporting, the threat analytics, being able to control remote systems, not actually having to be logged onto them. Those are, you know, those are all things that we do. And again, we could go into this in a lot more detail. I think there's actually even a poll towards the end of this if you want to follow up. So we could definitely come back and revisit some of these items in much greater detail. So, you know, a few things, again, some of what I would say would be like the highlights of our solution. I've already kind of hinted to this, maybe even outright called them out directly. So centralized policies, centralized logs, that's not synchronization. That means everything is stored directly in a central location. It's component-based, so we're highly scalable. You can have, you know, we work well in environments with 20 Unix boxes, 20,000 Unix boxes, 200,000 Unix boxes, and we've got deployments of, you know, all of those different sizes. Centralized session recording, again, when you're in an interactive session, that session recording data is stored directly on a dedicated central server. We do remote host control, so sudo is very single host based. We allow you to issue a command on what we refer to as the submit host, as in where I issue the command, but the command itself can actually run, or even the session can run on a completely separate host, which is for us the run host. And that actually doesn't require SSH, so it makes it really easy to lock a server down, but still allow those key activities to occur on those servers. And again, I kind of hinted to this one as well. Our policy language is dynamic and a lot more powerful. You have a lot more capability to do things like, I'll just give you one of my favorite examples that everyone seems to be jumping on right now. ServiceNow has become very popular, so before somebody can actually start a privileged session on a system, we can actually have our policy language go out and connect to ServiceNow, validate that there's an open incident of a certain priority, maybe assigned to a certain group or user before it actually allows that session to take place. And then also within our policy language, we can allow you to do things like ServiceNow updates as you're working through an incident on a system. So it's capabilities like that really take us way beyond what you can do with you know, with a simple sudo structure. So advanced audit and control, again, I've kind of talked to this at a high level already. I think probably one of the things that most people like is the ability to audit activities inside of scripts. It actually does give you full system level control. So again, you could give somebody a root level shell, let somebody log onto a system as root, but limit them from maybe going to the /home folder. And this is on top of the file system controls. So again, when Kristen was showing the permissions masks on files and folders, and you know, keeping aside any special permissions, this will actually be centrally controlled and apply on top of existing permissions. So even if root, well, obviously root can take ownership of anything, but if you had a home directory where root was the owner and the group owner, and you gave it a permissions mask of 777, we can still stop root from even being able to list the contents of that folder, let alone being able to move inside the directory or create stuff or manipulate with people's files. So root may have a good reason for being on a system, doing some diagnostics and upgrades, whatever's going on, troubleshooting, but you maybe want to make sure that you want to stop that active root user from being able to snoop around users' folders, like they just by blocking them out of the home folder. So file integrity monitoring, again, I've already touched on this as well, so I'll go very quickly over this. It's built into our least privilege solution. We already have an agent on the box anyway, so we use that to scan for target file and folder changes. And there's a whole nice simple web view you can use to set up your policy on what it is you want to track and how you want to track them, and then get that, again, centralized reporting so that you know the when we're talking about the who, what, where, and when of least privilege, that what has to be secured as well. Again, commercial solutions, you're going to get a whole bunch of reporting, scheduled reports. You can do custom reporting. We generate a whole lot of data, as any security tool will. The main thing is being able to make use of that data. There's no good generating a whole bunch of security logs if you can't identify threats within the security logs or actually see what's going on in the system. So again, that's just probably a half-an-hour topic right on itself. So just got a few screenshots there to show you some of the reporting capabilities that we offer. So architecturally, again, I don't think we need to go into any detail on a call like today, but the main thing is really noticing that the green box is the client where you issue commands, and the blue box is a completely separate part of your infrastructure which checks things like your policy, that does your event logging, the who, what, where, and when, does your session recording, makes it a video recording of that user session. Obviously flows all of that back into your analytic tools. That's we've got our own, which is Beyond Insight. You can use other SIMs like ArcSight, Splunk, that sort of stuff. All right, so we're really right out of time, so I'm actually going to skip the product demonstration today, but I believe in the last poll, I'm going to turn back over to Sarah right now. She will offer up the chance to actually see more details on our solution or solutions, which would actually also include a product demonstration as well.
Yep, absolutely. So the last poll is up on your screen right now, and as Paul said, if you're interested in being contacted by a Beyond Trust rep to talk further in further detail, or to see a demo, not just a more thorough demo, but an actual demo of PowerBroker for Unix, Linux, or any of our other PowerBroker products or Retina, select yes, and then somebody will be in contact with you to set up that demo, and we would love to take you through that conversation and through that demo. So select yes if you're interested in that, and let's jump into just a couple of questions. We are at the top of the hour, but Paul, this came in for you. Can we tunnel an SSH session through PowerBroker password safe?
Yeah, absolutely. Well, again, there's a really long answer to that, so it's probably best for now just to say yes, but it's a common practice that sometimes we use PowerBroker to, or password safe to check out an account, but then use PowerBroker Unix and Linux to control what that user can do within their session. So that's, it's a very, very common use case, but yes, absolutely.
One more question for you, Paul. We use sudo today, and is there a migration option for sudo, from sudo to PowerBroker for Unix?
So yes, again, that's probably a more detailed conversation. We offer a number of ways in which you can move on from sudo. So we've got like a stepping stone approach where you can start out by just centralizing control of your sudoers file. So we'll actually bring you some, the PBO infrastructure will allow you to centralize your sudoers file, have a single sudoers file applied to a single host or group of hosts. So that's like step one. Then we have two migration options to take that sudoers file into a PBO policy style. And normally we'll recommend some sort of professional services to help with that. The only reason being is if you simply transfer your sudoers file into a PowerBroker policy file, you don't get all the benefit, all of the extra power that you get with the product. So we're normally trying to point out areas that are weak or can be improved. But yeah, there's a number of options basically, and yes, we can absolutely do that.
Alrighty, you guys. A reminder too, I did receive a couple of questions asking about the recording and the follow-up. So yes, you will be receiving a follow-up email within 1 to 2 business days from now, and it will come from communications@beyondtrust.com. So look out for that email, and it will include a link to the recording and the slides shown here today. So you can review back, you can share, rewatch, whatever you need to do. I know there's a lot of information that Christian shared, so definitely use those assets to your advantage once you receive them via email. And a big thanks again to our speakers, Paul and Christian. Thank you guys so much for being here today, and a huge thanks to all of you guys who attended live. We appreciate you all, and we will see you at the next one, and have a wonderful rest of your day. Take care, everybody. Goodbye.